Okay, it's now been approximately 20 minutes, and we're going to go back and measure the pH of these two solutions from the saturated paste extracts. You'll notice that over time, the soil has settled down to the bottom of this, so what I'm actually measuring the pH of now is this somewhat clear, but yet also cloudy, of course, supernatant solution that's setting on top of this particular soil sample. Now, when I place my pH electrode into this, it's important that I do not place it into the soil itself, but just into this supernatant solution on the top. Now, as I place this in here, we had a pH of approximately 6 for this tap water. When I place this in here, we'll see a change in the pH reading. We have to give it approximately 30 seconds to a minute to equilibrate, because this is not an instantaneous reading. Remember, we're having to allow those hydrogen ions to go into that electrode. We can see here that this particular sample of soil actually has a pH up near or close to neutral. I believe it's reading approximately 6.6 to 6.8 on the pH scale. So this soil is just very slightly acidic, and actually anytime we get above about 6.5, it's really considered to be a neutral soil from about 6.5 to 7.5. Now, this particular soil sample, even though it's high in clay, came from not at the top of the soil profile but further down, and it's not unusual to see higher clay content subsoils not be all that acidic, because they still have appreciable amounts of the calcium and magnesium, or the basic cations, which have been alluviated down and deposited with the clay at that level. It's been approximately long enough now, and we're going to say this pH is approximately 6.5. It's about equally or halfway in between the 6 and 7 on the pH scale. Now, digital pH meters, which are also quite commonly used, are going to give us a little more accurate reading than that, but if we're within 1/10 of a pH unit, that is not going to significantly affect the availability of these nutrients based on solubility in a given pH soil. Okay, when I remove it from this solution, I need to go back into the distilled water and rinse the electrode. I don't want to cross-contaminate samples or take soil or solution from one sample to the next. So I'm going to give it approximately 30 seconds or so in that particular solution to come back to where it should be. And you can see that we're coming back down to a pH of about 6. Rinse it around a couple more times to make sure we've removed the soil. It may have been picked up from the previous sample. Now, the next saturated paste extract that I'm going to place this pH electrode into is the one where we use the calcium chloride solution. And you'll recall the calcium chloride solution should have driven hydrogen ions off of the exchange sites. Even though the active pH of this soil is not that acidic, it's only about 6.5, we should still have a significant number of hydrogen ions on those exchange sites that will be driven off by this calcium chloride solution and therefore cause a decrease in the pH of this soil. We could have two soils that had an active pH of approximately 6.5 and see quite a difference in the level of reserve acidity when we run this calcium chloride saturated paste extract test. Of course, the soil that depresses the greatest amount with the calcium chloride extract will be the one with the higher level of reserve acidity. So I'm going to take the electrode now, place it into the extract here. And what we're seeing is a drop in pH, as I indicated we should see. Although in this particular case, it's not all of that dramatic. So we're seeing the pH here going down to a level of approximately 5. So what that's saying is the active pH was 6.5 was our reading. The pH with the calcium chloride extract was at a level of 5. This is not 1.5 pH units is not a large depression in terms of the reserve level of acidity in the soil. So this particular soil then we would indicate does not have a high level of reserve acidity, rather it would take a lesser amount of lime if we needed to elevate the pH on this soil than say it would one which had a greater depression or a lower pH when we measured reserve acidity. I think it's pretty stable at approximately 5 in this particular case. So I'm going to place my electrode back into the distilled water, clean it off good. And that really completes the information you need to complete Part A of the lab and have a feeling for active and reserve levels of acidity in the soil. So now we'll proceed back to procedure B. It should be long enough now to where our extracts have passed through the soil and we've been able to extract both soluble as well as exchangeable calcium from those two soil samples.